Oh man, this is annoying.
Andy. Morning, guys. Before I show you a few things, anybody who just logged in have any questions from homework or anything? So everybody's doing okay with that, I guess, hopefully. I'll tell you this, you should definitely have started 1-2, if not finished it by now. So that's where you should kind of be. All right, so let me show you a couple things as more people come in. Ooh, where are you? There you are. Okay, so here's a little, I can't remember if I told you this before, but I put a little video about how to view the notes that I put on your homework. So if you're not sure how to see my feedback through Canvas, just watch this little tiny video. It's like, what, 2 minutes, 3 minutes? Very short and sweet. There's also this here. So if you miss a lecture, if you want to rewatch a lecture, you can click here. It'll take you to YouTube, so you can watch that. Make sure you look at Math 96. I do teach Math 176 and Math 160 also, so don't start looking at those videos and freaking out. Let me think, was there something else here I wanted to show you? No. Oh yeah, one little thing. I don't know, I still get people asking about homework. Here it is. There's all the homework for the whole semester. I like it. So if you look at, well, shit, I can't do that here. Okay. If you look at 1.2 homework, I did go ahead and put the screenshot of it here, okay? I'm not gonna do that the whole semester because it's not good enough. That's not the whole book, that's just the homework. You need the book. So just let me know. I might do 1-3, but I'm not gonna keep doing that the whole semester, so you've gotta have a book coming. But let me know if you have issues with that. I can work with you individually. I'm not gonna do this forever. Let me think. There was one other thing. Oh yeah. Let me stop sharing. Here we go. Something else that is threatening to drive me a little insane. That's not the right tone, Jeff. I know. It's just true though. So here's, for example, here's the 1-2 homework, right? 1-2 homework, yay, 1 through 5, and then up to 11. And when you get to 11, you are not done yet, right? I mean, if you look at the homework sheet, the homework is 1 through 11, and then page 33, number 1 and 2. Here's number 1 and 2, right there, right there. So the reason I do that, the reason I make this a part of 1-2 homework is it's supposed to be getting you ready for the next section. So it makes sense to do it before you do the next section. Is everybody with me? So a few of you guys are turning in like 1 through 11, but then you're not done yet. You haven't done all the homework yet. So I'll just tell you, finish it, you know, finish it. All right, enough of that. Bam. Perimeter from 1-2, okay. So let me see, let me share this again. We did discuss this before, but real quick. Perimeter is so much easier than area. Area gets disgusting. Like the area of this is not difficult. And again, this is not a question about area. Just let me go off on a tangent just for a minute. And you're like, we do that all the time, Jeff. The area of this shape is not difficult. The area of this shape would actually be kind of difficult. And the area of this shape, screw it. But the perimeters are all equally easy because all perimeter is add up all the sides. There's no formula for perimeter. It shouldn't be. Some of you guys know 2L plus 2W, but forget that formula. Forget it. Gives a shit. Just add up all the sides. So the idea of perimeter is easy, but what's wrong? Who remembers what's wrong with number 6? Why can't I just go 5 plus 10 plus 5 plus 10 and I'm done?
They're not the same units.
They don't have the same freaking units. So you have to make sure to turn. And normally it's easier to turn bigger units into smaller because that's multiplication. When you turn smaller units into bigger, that's division. You guys semi with me? How would I convert yards to feet? I would take 5 yards and I would multiply 5 by
3.
3 because for every yard there's 3 feet. So that's an idea of multiplication. That's why it's easier to convert bigger into smaller because you're chopping it up. There's no fractional parts then. Okay, maybe. Is that all right for that question? Somebody asked me that question, I think in the chat. Yes. Can you go over problem 3, page 31? Let's see. I can't. Oh, okay. I'm not going to be Jack. Will I go over? Yeah, shut up, Joe. Yes, I will go over it. Hold on to me. All right. So this one here, right? I'm guessing. I'm not sure who was chatting at me. I can't see my chat. There it is. Wendy. I'm going to say yes, because that's 3 on 31, I think. Yes. Okay, good. What was the difference? So tell me, look at me. If there's a, let me see how to say this. If there's a pot on the stove and I'm heating it up and it's 90 degrees and then a few minutes later it's 98 degrees. What was the difference in temperature?
8 degrees.
Yeah, what'd you do? 98 where it ended minus 90 where it began to see how much it changed. Is that cool? In fact, that idea doesn't give a shit about what the actual numbers are. It's always where you ended minus where you began to see the difference, right? So what was the difference between 2008, 2009? So where did I end? 3 billion, 2009. Where did I begin? Negative 15 billion. So how do I find the difference? Where I ended minus where I began. Same thing you always do. Don't let the numbers themselves get in the way. Now be careful, the answer is not anything to do with 12. Because how do you do 3? Let me see if I can write on this. Oh, I hate using this annotation thing. Where is it? There it is. All right. So if I do 3 minus negative 15, that is what that work should look like. End minus beginning. And of course, how do you do that? What's minus a negative?
Addition.
Yeah, they cancel each other out. It becomes 3 plus 15. And it makes sense. It takes 15 to get up here and then another 3. That's why you end up adding. So all the way through it makes sense, is my hope. Is that all right? Yes. Wendy says yes. Okay. All right, guys. Anything else from homework or in general, or how does Canvas work, or you're welcome. It's my job. I understand. I appreciate the thanks, but.
I have a question. So when is homework due? Like, is the section 1 through 1.1 through 1.4 due at a certain day, or are they all individually due each day?
Let me show you. Let me show you something. All right, let me see. For example, I got to look at it what it looks like from your perspective. Hold on. Sorry. There we go. Okay. Oh, this is going to drive me insane with all the sharing screen. Okay. So if you look at a homework assignment, shit. In fact, you can see it right here. Doesn't this show up for you when you look at the modules? This was due August 18th. This was due August 19th. 1.1 is due August 23rd. You guys see that?
Okay.
I
I
just
see it.
changed 1.2 to August 25th because a couple of people finally told me they didn't have a book yet. So I uploaded the 1.2 homework screenshots into the 1.2 module. I love all the words I use now with this. Sorry. So you can now, if you click on it, if you click on 1.2, you will be able to see the actual homework itself. I think I just showed you that earlier. There it is. So I made the due date tomorrow after, night. So if you don't have the book yet, now you can access the homework at least and do it for tomorrow. Everybody with me?
Okay. Thank you.
I like it. So something to learn from this is I have set up the course and I have made due dates and I have done all kinds of things, and I'm thinking everything I'm doing is exactly what is needed. With enough communication from students, I can change something. I can change my mind. I can go, okay, I think that's right. I think I should do this instead. Right? That's why communication is so important, not just with me, but with every instructor. And will you hit asshole instructors? Of course you will. Do you still try to communicate with them? Of course you do. Right? Yeah, sorry. I have no idea where that little PSA came from. Public service announcement time. The more you know. Boop, boop, boop. All right. Anything else, guys, before we get into the next thing? Okay, let's get into the next thing. There it is. Okay. O'Reilly. I have no idea why I have random commercials in my brain. So what I want to try to do now is to do a couple out of the book. If you have the book, I'm going to be on page, where'd it go? I love how I move around in this thing. 36. If you don't have the book, I'm going to put it up on the screen. Shabam. All right. How many guys out there drink coffee? Anybody drink coffee? Anybody have the correct size mug? At least this big is the correct size. Okay. Coffee's bad, okay? But oh well. There's actually a neat video about how coffee might have led to the Enlightenment. Because before that, we were having beer for breakfast. I don't know if you, that's a very interesting thing I learned. We had beer soup for breakfast, and then coffee came, and then the Enlightenment happened. All right. So this is all about some coffee, and I have to admit, I do like Starbucks, but I love going to a place where I can just say medium. But all right. So this person, the author, doesn't do coffee. That's crazy. A venti cup costs $2.45, and I love this. Really, yes. I mean, Starbucks is Italian for really expensive coffee. Suppose that a regular patron buys 2 of those every day. How much would they spend in 1 full year? I love this problem.
Is that a leap year?
Oh, don't give me an answer, but you can ask me a question. If you have an answer, hold on to it, because I want everybody to have a chance to try it out. Do you have a question, Cameron?
Is that a leap year?
Good question. Beautiful. See, this is beautiful. They don't say, do they? So if they don't say, we have to assume it's a non-leap year. So how many days are how many days are we working with then?
365.
Yes. Very good question. I appreciate that. Leap year, she has like 5 cups of coffee on the extra day just to, you know, make it through that longer year. So what I want you to do right now is to try to do that problem. Do something. Give it a try. You know it's 365 days in a year. Each cup is $2.45, and she gets 2 of them. Every day. And I will, so this one says, feel free to use a calculator. You can use a calculator, but you have to show me what you're putting. You have to show me the setup. Don't just suddenly have a number come out of nowhere. There's sort of a couple different ways to do this. All right. So somebody, what did you get? Let me get a couple of answers. Somebody want to hazard a guess as to what the answer is?
$1,788.50.
Pretend that's what that says there. That's one guess. It could be right, could be wrong. Did anybody else get something different? Like you're all like, we're all in, man. Either we're all right or we're all wrong. Deal with it. I am Spartacus. All right. Oh, I got somebody chatting at me.
It's
Stay.
1,764.
Say, sorry.
1,764.
So then I got 1,764.
Yeah.
Okay, that's another guess. Okay, and then a few other people got 1788.50. All right, so let's find out. Let's find out. Can somebody else who hasn't spoken yet? Anybody? And you're like, I haven't spoken because I don't want to. But can somebody, just somebody tell me, how did you set this up? Somebody else. Anybody? I don't like calling on people. I'm not going to start, but
I did 2.45 times 2.
and what does that by itself represent?
The day or the amount of the coffee times the 2 days, 2 times a day.
Okay, I like it. So what does that represent then?
Oh, $4.90
And that's how much she pays for coffee
Per day.
per day.
I love it. Cool. So it makes sense, right? And why am I, and real quick, this is a relatively simple problem. So I hope you didn't have a lot of trouble with it. But what I'm doing right now is something called unit analysis. So if I know how much money she spends per day and I multiply it by a number of days, my answer has to be money, right? Because the per day and the days canceled. So that's something called unit analysis. Become big later. And then, of course, we're going to multiply this by
365.
kick ass. So then you get, see now, look at that. I love it. Somebody was writing up there, so I just thank you guys for being able to write on my paper. So 490 per day times 365 days. And of course, when you do that, you get
$17.88.50.
I like it. So I'm curious. It's interesting. So that's 24.50 less. I don't know if that's just didn't multiply by enough days. Whoever said this, do you see what you did wrong?
Yes, I'm sorry because I didn't include the Sundays.
Oh, I see. I understand. So they didn't discriminate. She said she just goes every day, right? Okay. Yeah, I used to only drink coffee during the weekend. Now I'm drinking it every freaking morning. But, oh well, it's too late for me, kids. Don't get on the caffeine. Don't do it. Is everybody cool with that one? That one is meant to be like really crazy hard. Okay. So number 6 says something kind of silly. Oh shit, what did I just do? I did something weird. Oh, that's right, I can't move without this coming with me. Look at this. You can write 490, 490, 490, 490 until you've written 490 how many times? The other way to do this here.
365.
Yeah, the other way to do this, what this really means, all multiplication is repeated addition. So if I wrote 490 365 times and then added them all up, that sounds like something an insane person would do, right? If you saw somebody in the room doing this, you'd say, we need to get Bill some help, if you're Bill. So then, yeah, 365 times, or you can just multiply like we did, right? So I pretty much just gave this one away. Multiplication is repeated addition. We know that from, that's how they describe multiplication in the first place. All right, I got to erase this stuff or else it's going to come with me. Here we go. I'm going to try this. Let's see what happens. Oh, cool. All right. Thank God. So now I got to stop doing this. All right, now I can move. Now this is interesting. Who's doing that? I'm going to go one step further than they do here. We're not going to do all these. So how much would she spend in one day? We know this already. We already did this work.
490.
Yeah, 490. That was 245. Oh yeah, times 2. Oh, Jeebus. I got to get myself a tablet or something. That wouldn't help, Jeff. 490. So now after 3 days, I would just do what?
Multiply 490 by 3.
Yeah, okay. So I think you get the, now let me, and the rest of this should be easy. Is that all right? Of course you do 490 times 10, 490 times 180. Ooh, so try this. How about if I didn't know how many days? What if it was X days? Not X-Men Days of Futures Past or whatever the hell it is, but what if it was an unknown number of days? What would it look like, the work I would have to do? Let me put it up here. Let's not do 180, let's do X days. Well, what did I do for 3 days? 490 times 3. What would I do for 10 days? 490 times 10. I really shouldn't use the symbol X for times. Well, what do I do for X days?
490x.
Yes, I like it. So all algebra wants to do is to tell you what you would do if you just knew what that number was. If I knew what X was, I would multiply it by 490. If I knew the number of days, I would multiply it by 490. So I want one extra step beyond what they did because this is beautiful to explain that part of algebra. That's what algebraic expressions do for us. All right, now take a second to see if you can do number 9. Just to remind you guys, up here we got 1788.50. You can see that in the chat. We got 1788.50 for Starbucks. What if she went to 7-Eleven instead and got their brown water? I mean, their coffee. I don't know why I'm knocking on 7-Eleven. It's probably fine. Take a minute. Now, how are you going to, well, let me see. How much would she save if she went to 7-Eleven instead? Or Circle K or whatever the hell it is she lives near. So take a minute, try to figure that out.
Can you hear me?
Yes.
Okay, so you want us to do number 9 right here with that?
That's right.
Okay.
So what I did was I put the answer we got for Starbucks.
Right.
And now they're asking, how much would she save if she went somewhere where it only cost $1.49 a cup?
Oh, okay.
That's gonna be a 2-stepper.
Yeah, you're gonna, yeah, okay.
Okay. Yeah, Daisy, everything else is the same. She's
Thank
still
you.
cups a day.
You want us to tell you the answer or wait?
Hold on for a minute. Thank you, though. And, you know, this is going to happen a lot through this course. I have students of all kinds of different backgrounds. So some of this early stuff we're doing, some of you guys might be like, all right, I know how to do all this stuff. That's great. Enjoy it. This is for the people that don't. Maybe it's been a long time. So really, the work is going to look the same, isn't it? How much is he going to spend at the McDonald's? It could be McDonald's, I don't know. At the 7-Eleven, it would be $1.49 times
2,
2 cups a day times
365.
365. I am going to show you a bit of a shortcut here in a minute. And what do you guys get there?
1,087.70 cents.
1,087?
Mm-hmm.
Oh, and how many cents?
70.
70 cents. Sounds about right, I think. Yeah, and then let me see. If you look in the chat, all you do now is you subtract these two. So how much did she save? 700, looks like, yeah, 780 cents. 700 bucks and 80 cents. I like it. You can do it, Jeff. Holy shit. So when you put things in terms of a year, it's kind of like, yeah, it accumulates a little bit. So, I mean, if the 7-Eleven coffee tasted just as good as the Starbucks coffee, hell yeah, I'm doing 7-Eleven, right? Or whatever the convenience store is. If it doesn't, then that might be worth the extra money. Does anybody have a different way to get that number quicker? First off, is everybody cool with the work that was done here? Ignoring how horribly written it is. Is anybody not cool with it? Okay. Let me do some work. Now watch. How much was the Starbucks coffee again? It was $2.45. And how much was the 7-Eleven? It was $1.49. So what's 245 minus 149? Nobody's getting it. 96 cents, right? Is that right? It could be wrong. I don't know. I'm doing it in my head.
Yes, 96 cents.
Thank you. And then if I do 96 cents difference per cup times 2 cups times 365, can somebody do that for me, even if you don't understand why the hell I'm doing this?
700.8.
780, yeah. So instead of calculating the 2 separate totals and then subtracting, I calculated the total difference for the whole year, right? And I'm almost certain some of you guys might have considered that or thought maybe it's something you could do. If you have no idea why that works, it's not 100% necessary for you to do so right now, but I just want you to think about why that makes sense. I subtracted first here and then accumulated all the differences instead of getting the total accumulation and then subtracting. Math doesn't give a shit. It's like you got the same amount either way. All right, maybe. Okay. Any questions? Oh, sorry. Go ahead. Did I hear that? Am I going crazy? It could be.
Hello?
Yes.
Okay, so what you just did the difference, and on the difference, you times it by the 365.
So you ready? If she goes to 7-Eleven, she saves 96 cents per cup.
Right.
So how much total savings? 96 cents times 2 cups a day times 365 days a year. Of course it comes out to the same number because it represents the same thing. How much did it save? Yes, good. I love it.
Mm-hmm.
I love it. And this, unfortunately, this points to something that happens in a lot of people's early math life, is you have a teacher who is not flexible and will not accept other ways of approaching problems and doesn't even tell you that your way is right. Just says, that's not the way I showed you. And that'll shut somebody down. And I'm almost certain if you thought back, if you've had a rough time in math, if you think back, there was a teacher that did something like that to you. I'm almost certain. In fact, some of you guys are like, I don't have to think back that far, man.
Question.
Yes.
So being that she had 2 cups, that would be double that, right?
That's right. So that's right. Right here is 96 per cup times 2 cups.
Right.
And then times the number of days. Exactly.
Mm-hmm.
Exactly. Okay. I'm going to clear all that. It's going to go away. Clear. Okay. Blah, 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 blah. Let me see. How much did this that I want to do? This gets a little bit interesting, but it's basically the same thing, just putting money into a piggy bank or something. It's the same exact kind of problem. All right, now here's where things get really interesting. And you're like, I think your definition of interesting is different than mine, but that's all right. Just take a minute and see if you understand the setup here. Let me blow this up a little bit. It's a little bit teeny tiny.
Hey, where?
Sorry?
What page is that?
Page 38.
Oh, okay.
Yep. How do these two relate? How does this one relate to this one? That might be a weird question, and I don't seem to care.
They're both dealing with
They're
energy.
both pie charts.
Okay, I like it. They're both pie charts. They're both dealing with energy. Can you find one of them in the other one?
The 10% on the one on the left is the one on the right.
Like it. So now listen. If 10% of students at Grossmont are left-handed, couldn't I take that group of students and then say something like 47% of the left-handed students like lima beans or something equally silly? I love it. Some of you guys are looking at me like, lima beans? Who gives a shit? Can't I take any subgroup and then just take them as a whole group and break them down again? Are you guys kind of with me? That's all they've done. 10% of the total energy consumption is renewable. And then they said, well, let's break renewable down. 2%. This is horrific, by the way. I always hate this kind of shit. But you can sort of see. So it looks like 2% is geothermal. 22% is solar. Normally, what would be a better thing that they could have done? Did they sort of do this wind, biomass? I guess they might have. Biofuels, wood, hydroelectric, solar. Okay, they did sort of put it in order. Do you guys see what I'm saying? So this is wind, and then it goes clockwise from there through the list. Otherwise, the colors like this blue and this blue are not very different. You guys, maybe it's just me. All right. So, this is going to be an interesting question. Let me see if you guys can get this. What percentage of the total energy consumption is, let's say, wind?
1.8.
And just hold that for a minute, Cameron. Cameron is completely correct. So 10% is renewable, and what percentage of that is wind? 18%. So 18% of 10%.
Mm-hmm.
Let me stop for a minute. If this whole chart, what does this whole chart add up to be?
100%.
100%. I love it. Stay with me now. Stay with me. Some of you guys are trying to assume where I'm going. Just hold on. This pie chart, of course, adds up to 100 like it's supposed to. But what does this pie chart represent in this one, this 10% slice?
10%.
Say that again. Repeat that.
This whole chart represents this 10%. Of course it does, right? Renewable energy. That's what we said earlier.
Right.
So if I want to know, wind is 18% of renewable.
Uh-huh.
But what percentage of total energy consumption is it? It would be 18% of 10%.
Right.
So another way I could look at this, and thank God they didn't do this, but I could look at this as taking this little slice and breaking it up into other little slices. This will be wind, and this will be, oh my God, that would have been gross. That would have been impossible to read. So thank God they didn't do that. Now, let's try a problem. Oh, shit.
Okay.
Now, this first one is going to be pretty straightforward. This first one actually just tells you the answer. It has nothing to do with renewable. It says the first chart shows 35% came from petroleum. Total is 98.3. Now, do not care about this, but has anybody ever heard quadrillion and actually understood that it's an actual amount?
No.
There's a lot. And then, of course, British thermal units, you got to love. But if you've dealt with any ACs or anything, then you know BTUs. That's just, it doesn't even really matter what the units are necessarily right now. That's not the point of it. So what does 0.35 times 98.3 tell you?
How much of that energy was petroleum?
Yeah, so it's converting it into actual energy units, not just percentages. So if I do 35% of the total amount of energy consumption, I will get the petroleum energy consumption. Let me stop for a minute. So if 35% of students got an A and there were 1,000 students, how many students got an A? 0.35 times 1,000. If there's 35% of the energy consumption is petroleum and 98.3 quadrillion is the total amount of energy consumption, how much of that was petroleum? 0.35 times 98.3, exactly the same idea. Grosser numbers, freakier units, same math.
Where is the professor the 0.35 scale?
What is 35% as a number?
0.35.
There you go. So how do you do 35% of 98.3? You do 0.35 times 98.3. And what do you guys get? What is that?
34.405.
34.405? Sounds about right. I have all the answers here, but I would just look at them, but I'm too lazy. Now, course number 2, why is number 2 kind of silly? Can somebody please help me out? Do you see what number 2 is asking? Compared to what we did here, does that have the same result? Do you even have to do it? Why does this have the same result?
Because of the
same problem.
multiplication.
I like it. So Cameron's getting very technical on us, which is beautiful. Nothing wrong with that. But it doesn't matter what order you multiply in, and that's officially called commutative property, right? Commutation. So the word commutative means that individual things can move around an operation. So like 7 times 8 is the same as 8 times 7. Is subtraction, ooh, that was my 18th puberty. Is subtraction commutative?
No.
No.
Because what is 8 minus 7?
1. No,
What's
8.
8 minus 7 is 1. And what's
1,
7
yeah.
and what's 7 minus 8?
-1.
What'd you call that? -1.
So subtraction is not commutative.
Right.
I love it. Is addition commutative?
Yes.
Because 8 plus 7 is the same as 7 plus 8. Is
Right.
division commutative?
No.
Because 8 divided by 7 is bigger than 1, but 7 divided by 8 is less than 1. So they're not the same. All right, let me stop for a minute. I really hope that I'm not completely bulldozing anybody like you lost me at good morning, Jeff, what the shit. You've got to stop me if something's not making sense, because trust me, it's not just you. But if nobody stops me, I have a tendency of just continuing. Right? Okay.
Question.
Yes.
Okay, so do you want us to use that language for number 2, or just what type of not commutative?
You don't have to say commutative. You can just say you can multiply any order you want to.
Okay.
By the way, before you get too excited, we are not doing the homework right now. This is right. Somebody out there is like, "Ooh, yeah." No, you still have your own homework to do. This is not from the homework section. I love it. All right. Let's see. Oh, okay. What about number 3? How many quadrillion BTUs were generated using renewable energy sources? So that's the same idea as number 1. You're going to take what percent of what?
How many?
Of 98.3 quadrillion.
Yeah, so there's still 98.3 quadrillion total.
Times 10.
Times 10%, so 0.10, right?
Yeah.
So same idea as number 1, just talking about a different category. So what about nuclear? 0.08 times 98.3. I mean, it's just a percentage times the total. I like it. So, let me see. How much of that is generated? Okay, now here's where things get more interesting.
Question before you go any further. Jeff, like when we what made you, when you put your 0.08, do you have to put a 0 in front of that whole number, is what you're saying? It got to be 2-digit?
Yeah, whenever you change from percentage to decimal, you got to move the decimal twice. So once would get in front of the 8, and then one more time would get in front of the understood 0.
Okay. Thank you.
You're welcome. All right. So look at this guy here. This guy, just the wind power. Just the wind power. So I'm going to reword this a bit. How much total energy was wind power? How much total consumption was wind power? Wind is here, which is related to this, which is here. So don't say anything. So there's 98.3. You can ask a question, I'm sorry, but don't say anything about the answer. You have a question?
No.
Okay.
No, I'm doing the question now. Yeah.
Gotcha. So there's 98.3 total. 10% of that is renewable, and 18% of that is wind. Don't say anything yet, but can you put all that together and figure out how many quadrillion BTUs was represented by wind energy? Don't say it yet. All right. So can somebody tell me what work they would do for that?
Being that, can you hear me?
Yes.
I got point. Oh, do you want me to tell you the work? Okay, because it's 10% of renewable energy sources in the whole.
Good.
I times 0.8 by the 10% and got my answer. Is that correct?
Where'd 0.8 come from?
0.1. What was it? 18.
Yes.
0.018 is what I came up with, but the
math. Okay, I'm with you. So we sort of did the first step of this earlier.
Right.
Let's step all the way through. You ready?
Right.
So renewable energy would have been 0.1 times 98.3, and then what percentage of that? Oh my God, that's a 3. What percentage of that would be wind? Would be 18% of that. You put a little 0 in front of there. So 18% of 10% of 98.3. Or like we did earlier, what percent of the total is wind? We got 1.8%, which like Linnell is saying, that would be 0.018. And that's exactly what this is. So this is 10% of the total, that's renewable. And then what percentage of that is wind? 18%. Let's freak you guys out. So this is where this sucks so much because so few people really understand percentages, and you see percentages all the damn time. And politicians love that very few people understand percentages. For example, if we lose a lot of jobs and then we gain a few, you could say, whoa, the percentage of job increase is the biggest in ever. Yeah, because we just had the largest ever drop in jobs before that. So it's, sorry if you think I'm being political, I'm being mathematical. And politicians, trust me, a lot of them understand math well enough to use it against people. And people don't know it well enough to really understand what the true message is. They just take the surface. Oh, we're doing a great job. No, sorry. Maybe I am being a little political, but oh, to it. Okay. So let's see. I think that's enough of that for the moment. Let me clear that. What do you guys get for that? I'm sorry.
Was mine correct there? Yeah.
Yeah, that's the right work. I just don't know what's the answer going to be.
176.94 trillion.
All right, let's try it one more time.
176.94 trillion.
Oh, I see. So you've converted it down because it becomes, what does it become? 0.17 quadrillion?
1.7.
All right, let me try this again.
What number is that at?
1.7. Yeah, just multiplying all this together, right? 0.18 times 0.10 times 98.3. Right? And this sounds about right. 1.7 what? 6?
It'd be 0.176. 0.17.
Yeah, that makes more, well, let's see. Well, let's do it. It looks to me like it should be. Yeah, 1.77.
Okay, is this the same question?
Yep. Quadrillion BTUs. Blah, 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 blah. We'll call them QBs.
Okay. So I have a question. So this is where I'm a little confused at. If we have 10% of the total of the 100, and then on the other side, you have 18% of the 100 equals the 10%, I'm just confused of how you're getting the same decimal of the 0.18 and the 0.10 if that's a larger, if technically the 10% is a larger number than the 18 if you're doing it in the total of the 100. Am I making any sense? Because I'm just a little confused about the decimal.
But you're overthinking it. I see what you're saying. The 18% slice, I want you to understand what you're saying is right, but it's captured by the work I've got down there. It is 18% of, so times this smaller slice of the total, right? What is in this slice? 10%
of 100.
3, right?
Oh, okay. Yes, the total amount of
that whole slice is. And isn't that, holy shit. All right, I got to figure out a better way to.
So what I did is I just took and see, I got the same number as everyone else, just in the wrong decimal point. Pretty much is what I did wrong.
Okay.
So I just did 0.018 times 98.3.
Yes, that should be.
So, but it should be the same. So then,
yes, it totally is. So
okay.
0.018 times
is out of the 100. That's this is where I'm getting confused because I'm.
That's the thing about. Okay, I like that you're saying this. The out of 100 thing has nothing to do with any specific problem. There's no 100 anything anywhere. Are you guys with me?
Okay.
If there were 100 BTUs, then that many BTUs. But there aren't 100. There's almost 100. But percentages can be used no matter what the total amount we're talking about is. So the out of 100 thing is just because they are 2 decimal places over from a full. That's what that does. Once you've done that, you're done with the out of.
Okay. Okay.
Yeah. It's kind of like 40% of 100 is an easy question because the 100 matches with what the percentage is based on. So what is 40% of 100?
0.4. Is that what you're asking?
No. What is 40% of 100?
40.
40.
Oh, okay.
Done. 40% is 40 out of 100. So what is 40% of 50?
20.
20.
20, yeah, half of that.
Half of that, because 40% of 100 is a certain amount. So 40% of 50 is my Wi-Fi weird shit. Oh, crap. So 40% of 50, of course, would be half as. Okay, maybe.
Yeah, hello?
Yes.
Was you waiting for a response? I don't know.
So, but I mean, you could have one. What's up?
No, I was wondering, you was talking and you just stopped. So I didn't know if you were waiting for an answer to see if We agreed, or did anybody have, questions? I'm
Yeah,
okay.
yeah, that's when I stop. I do that to see if anyone has questions. But I didn't really ask a question, but
So basically, you just split it in half
for
on that
40%,
particular
for the
question.
40% example we just did, yes.
Yeah.
Yes. And that's a quick way to do certain percentages. But I'm not sure if I can fully explain the issue with the out of 100. Everybody thinks that has to come into play, but that's already built into the percentage. You don't have to bring that in somehow, unless it makes the problem easier to do. Like we just did with the 40% of 100, so 40% of 50 is easy. It's just half of what it would be if it was 100. But now I got 98.3. Screw that shit. I can't consider the out of 100 thing. I just do the work. I just do what the math says to do. All right.
Okay, and then on the question, on the question 4, where I got to 0, how much it was, right? And he came up with 17 something. So that's
1.77.
1.77.
Yep.
Okay. So what was done was just times the 0.0818 times the 93.3.
Can you guys see that? Is that
No, that's blurry.
blurry? Sorry, I don't know if I'm going to be able to.
Yes, it's just blurry.
All right, you ready? Wait, hold on. It's still blurry, I know. Is that better? You guys see that? That's what I put in the calculator. You don't have to have this kind of awesome calculator.
Right.
Scientific calculator, whatever. But that's what I put in. And I put it in 2 different ways, right? And of course, it comes out to be the same. I like it. All right. I look blurry. Okay, there you go. Woohoo! Now, if I were you, I might be sitting here thinking, holy shit, what does my homework look like? So let's take a look at the homework real quick, just to kind of get a preview of what you're going to have to do. Hold on. Let me get there. Let me undo this. Bam. There we go.
You rounded that 6 off to a 7, huh?
I just made it, yeah, just to make it quick. So, I mean, here's what your homework looks like. It's going to be a little more straightforward. It's going to be actual problems that you might have in real life. And it's really going to be just, again, sort of like what was earlier. A lot of this is going to involve multiplication because that's the point of this section, but some of it might be writing things with repeated addition because that's what multiplication is. Oh, I like this one. I love this one. And this one shouldn't be that big of a deal, but we'll see what you guys think. It kind of is a visualization of how multiplication and addition are connected. Yeah, all right. So the homework, my purpose for showing this is not to get deep into what to do for each problem, but just to show you that it's not going to be quite as freaky as what we just did. So almost always, anybody play any basketball at all?
Yeah.
Some of you guys? Have you ever heard of, there's a basketball you can practice with that's a little bit bigger than a normal basketball? Did you ever hear that? No? Why do you think it would be good to practice with that? Because
easy to handle in the real game.
No, that would suck. Because if you can get that slightly larger basketball to go into the hoop, you could definitely get this slightly smaller basketball to go into the hoop. So does that make sense? So a lot of times what we practice together will be a little more difficult than what you have to actually do yourself. Same reasoning. So we use a slightly larger basketball when we're working on stuff together sometimes. Okay, maybe. Some of you guys, I know from the beginning I've lost you, and now you're like, he's talking about basketball now, and I thought this was a math class. Shit. Okay. Let me see. Was there anything else I want to show you? And again, just to remind you guys, just to make this point again, you're not done with 1-3 homework if you get through number 8 done. You've got to also do these. And then that will be the complete homework for that section. I like it. All right. What time we got? It's 10 o'clock. Let me see. Do you guys have any questions? So you want to go back over anything, or where am I? There I am. We kind of did some weird stuff today. We'll see what you guys think. That one with the percentages is huge, though. It happens all the time, and you hear it all the time. I don't know how you guys get your news anymore. And if you get your news from Instagram and that's it, I'm a little concerned. Or TikTok, because you never know. It sounds like Trump wants to kill TikTok. So who knows if that's going to still be around. You're all dancing the news at each other. I don't know. Here's the interpretive news dance for today. I don't know what you guys are doing. I have no idea. So enough of that. But I'm just saying, even if you don't look for news, see a headline, research a headline. I love it. Kick ass. It's like see something, say something. Never stop at the headline is what he's saying. And don't even stop at the article. You got to, anyway, this is not research class. I'm sorry. All I'm saying is you will run into percentages, and you know you do all the time. If you understood percentages fully, you can really see what they're trying to say or see how you're trying to be manipulated sometimes. And that's kind of my mission is it's easier to participate in government, in decision-making, and all that kind of stuff if you understand basic math, because otherwise you can be manipulated easily. And you don't want to let that happen, right? Okay, that's enough. That's enough of a lot of PSA today. I'm sorry. Otherwise, I think I'm done. I can let you guys out a little bit early. If there's no other questions, if you want to hang out a little bit afterwards and ask questions, you can. If you don't want to, it's okay. You can head out.
Oh, okay. Okay, so so they're just checking out. I'm gonna ask a question or two because I'm on the catch-up lane, but I'm starting to catch things a little better here.
All right.
When we're dealing with 1-3, we're gonna do number 1 through 8, and then you want those 3 where they're discussing this thing on lesson 1 through 4 on the next page.
Yeah, it's kind of like a preview of 1-4. That's why I make it part of 1-3 homework. That's right.
Okay.
So 1 through 8, and then you do the next page, page 45. It's actually on page 46, the prep skill questions.
It's on 46?
Yes.
Oh, okay. So you want those 5 questions answered?
Oh yeah.
Okay.
Hopefully that's what I said in the.
Right. I thought you said though. I was looking at the bottom, but that's still explaining. Yeah. Okay.
Here it is. Yeah, page 46, 1 through 5. Yeah. So that is this part here. This is a part of each of these. So section 1-3 homework includes page 46, 1 through 5. I like it.
Mm-hmm. And when will you be open this week for a tutor class?
Oh yeah, shit. I did finally just yesterday find out the remaining meeting times for the other stuff. So I'm going to set up some other hours. I'll email it out, or I'll put it up on Canvas when I get that done. Okay.
Okay. Whenever that is, then I could just go ahead and put it into my agenda.
Yeah, I like it.
And then catch up a bit.
What I'm thinking about doing is I'm going to make some extra office hours for all of my classes, and then I could break people up based on what class they're in. Hop into each room, and then let people help each other out, and then I can help a lot of people out at once.
Right. That sounds great. That's a great idea. Yeah. The dots are starting to connect. Not as fast, but they're connecting.
Yeah, that's the important thing.
Appreciate your help.
Sure.
All righty. Have a good one.
You too, man. Is everybody else all right? You guys all right? You guys just hanging out? Don't want to miss anything?
Professor,
Yes.
sorry, I submitted section 1.1 and section 1.2 like separately, and today I will again I will submit section 1.2, the homework, because I think for the first one I submitted separately. I make it like 2 pages separately.
Not sure what you're saying, because I know the 1.2 that what you turned in for 1.2. There's 1.2. No, that's somebody else. Sorry, you're Sam Nazari. Okay.
I think I submit, yeah, for 2. I will remove this one and I will put again to the section 1.1, because this is the rest of the section 1.1.
Yeah, that's the problem. Yeah, I don't even see where if you did turn in 1.2, I don't see where it is, because I just see 1.1 homework in 2 different places.
Mm-hmm. Okay, tonight I will submit the section 1.2, and the section 1.1 is already I submitted, and I don't know it need to be submit again or no.
1.2.
Yes.
Like I said, I don't see section 1.2 anywhere. So if you think you turned it in, I don't know where that is because I don't see it.
Okay, I will submit today. Tonight I will
Make sure to
submit.
turn it in where it says 1.2.
Okay, Professor. Thank you very much. Have a nice night.
You too.
Thank you.
How are you guys? Joel and Wasan, are you guys okay?
Yeah, I have a question. It's about my submission of the assignment, the section 1.1.
Okay.
I don't know, like the first page for the pie graph and bar graph. I don't know, you did like the errors from place to place, but I didn't understand what you mean by that.
All right, let me look you up here. Oh, number 2?
Yeah.
Okay, just what you did is fine. It's just better, unless they say to do it like that, you normally put them so the bars are going up and down.
Mm-hmm.
That's all. So I just said it should be flipped. But,
okay.
It's not I didn't take any points off. I didn't say it's wrong. I'm just saying normally you make it like that unless there's some real reason to do it the other way around.
Okay. I looked at the other bar graph. That's why I did it this way.
I'm with you.
Yeah.
So that's why I didn't say you have to redo it or something. It's just normally you do it the standard up and down.
Yeah. And I did a mistake like submitting section 1.1 to section 1.2 by mistake. Yeah. And so can I do like put it again, like resubmit it to 101 or just leave it there? I don't know.
So let me see what happened here.
Yeah.
So you turned in.
You can see you said I didn't finish it. So yeah.
Well, you turned in part of one. Oh, I see.
I did both of them, but
you're fine. So it looks like it's fine.
Just leave it, or
yeah,
should
but
I
did I
submit
give
it?
you credit? Hold on. Did I say you had to finish 1.1 homework? Is you know what I mean? On your 1.1 homework, what did I say here?
Yeah. No, just just finish the rest, the page 19. So I did it by mistake on section 1.2 submission on 1.2.
Okay, I see. That's right. So I'm going to put a note here for myself. Well, wait a minute. Was there any wrong? So then you're fine. I'm going to change this to okay then.
Oh, okay.
The only problem I had
with that, incomplete. Yeah,
so I'm going to make it complete.
Okay.
So that's what I was curious about, is if I remember to come back here to make this complete, but I didn't. So I'm going to make this complete now, and you're good. Okay.
Yeah, and I have one more question about the review. I resubmitted my correction. to that. So now it says late, so it doesn't matter even though
Oh,
it's
that's
just
another thing I forgot. Of course it's going to say late.
okay.
And I can see on my end, I can see that you turned the original in on time, and I can see you turned the corrections in late, because the corrections are always going to be late.
Yeah, yeah.
So don't worry about that. That doesn't
Doesn't
sound
matter.
make the whole thing late, you know, because I could still see the time you turned in the original, and I know it was
Yeah.
on. Yeah. So I
Yeah.
forgot to say something about that.
I
It's-
wanna just make sure that
Yeah.
I don't have anything on. Yeah, I think that's all. Thank you.
You're welcome.
Thank you very much. Mhm.
All right.
Bye.
See you